kilometers, whatever the downtown Washington DC size is, we squish the atoms to the point where their electron clouds are essentially pushed inside the nuclei, which in turn are touching each other. So everything has a lot less space now, very crowded indeed. When you really compress something like our sun to such a small radius, the atoms, same as the title of this book, atom, they're not as comfy. They don't have as much space. They don't have as much space, okay? They really don't. They really don't. Wow. So everything's touching everything. It's like, oh my gosh. It's a little bit like where I'm from, Kolkata. Very populated indeed. And you don't have a lot of personal space there. So the entire mass of the sun is then essentially like one huge atomic nucleus. Goodness. It's almost like everything is touching everything. Which one is which nucleus? Which one is which electron? We don't know. All the atoms are like uncomfy. Nuclei are touching each other. Electrons are touching each other. Everything is like, you know. So it's almost like it's one huge atomic nucleus. One huge. Almost like same everywhere, right? As bizarrely unrealistic as such a scenario for an object like the sun may seem, it actually happens about 100 times every second in the visible universe. Oh my gosh, oh, I love that. Hello, nerd. In our own galaxy, about once every 30 years, the inner core of a star ends its life. See, he's talking about supernovae. He's talking about supernovae now. Oh my gosh, oh, I love it. And did you know, in our own galaxy, about once every 30 years, the inner core of a star ends its life in such a state after a massive stellar explosion, a supernova of the type that created us. See? I told you about gas nebula and about gas clouds condensating and cooling to make us. See, now he's talking about it too. If I had a professor like her, I would have a PhD. Aww. Well, you should definitely go get your PhD. Many people do. If I had a professor, can you believe it though? Can you believe it? As bizarrely unrealistic as such a scenario seems, where the sun's things are all close together, same everywhere, it actually happens about 100 times every second. That's how common it is, and that's how much stars die to make people like us. Oh, isn't that romantic? Let us keep on compressing. PhD takes like 10 years to earn. So, are you calling me old? I did go to school for 10 years, it's true. It's more like 9. I did 4 years undergrad, 5 years PhD, so 9 years in school. Not that bad. So, let us keep on compressing. Take this gigantic solar atomic nucleus of mass, 10 to the 56 times the mass of a hydrogen nucleus. So because you've compressed it a lot, it's kind of like one giant nucleus, right? So it's a 10 to the 56 times the mass of a hydrogen nucleus because of all the different nuclei that's in there. And compress it further by another factor of 100,000. So that a single teaspoonful of material now weighs 1 million billion tons, the mass of 1,000 Earths. A teaspoon of material of this more compressed sun, in imagination, would weigh 1 million billion tons. The sun is now the size of a basketball. So, if you compress the sun somehow to the size of a basketball, no worries, you would just make a teaspoon of it weigh 1 million billion tons only. So then what happens? We'll see. I'll be out in my 50s. And you'll be 50 even if you don't get a PhD. So just get a PhD. I think we will all turn something at some point, and that's no excuse to not get a PhD. If you want a PhD, go get it. You'll be 15 regardless. However, there are about 400 billion suns in our galaxy. And actually my office mate in grad school was in his 50s. One of the office mates. I had a very large office in grad school with the blessing of the universe, and I had 2 office mates. And actually I